Hi, my name is Diane, and I'm going to present my project, which is BionanoPCL PVA carriers fabricated by ultrasound assisted microemulsions for target catechin release. First off, oxidative stress is an imbalance between free radicals, and due to the disproportion of these two molecules, it can contribute to the occurrence and/or development of diseases such as leukemia. Antioxidants play an important role mitigating oxidative stress by neutralizing free radicals, and that's where catechins come in. Catechins are polyphenolic compounds which belong to the flavonoid family. The sources where you commonly can find catechin are peanuts such as hazelnut, walnuts, pistachios, coconut powder, or dark chocolate, green tea, red wine, and various fruits. These can be found in several forms such as epicatechin, epigallocatechin, epicatechin gallate, epigallocatechin gallate, and although all exhibit remarkable biological properties such as antioxidant activity, anti-cancer, anti-inflammatory, neuroprotective, cardiovascular benefits, and antimicrobial activity, EGCG has stand out for being able to enhance those qualities. According to some preclinical studies, which include in vitro and in vivo experiments, it has been shown the positive effect of EGCG on leukemia cells. Administered catechin compounds were able to induce cell apoptosis in acute pro-apoptotic leukemia, APL, as well as degradation of PML, oncoprotein, and inhibited APL cell proliferation. The anti-cancer activity in EGCGs display the ability not only to interfere with cancer hallmarks, but also to interrupt various signal pathways associated with cellular proliferation. Furthermore, evidence demonstrated that catechins are capable of disruption of survival signaling pathways by regulating the redox balance, inducing oxidative stress. Additionally, they can modulate epigenetic alterations, including DNA methylation, and exhibited promising results in promoting the differentiation of leukemia cells. In my methodology, I started first doing the serial dilutions. For that, I prepare a stock solution of 0.5 grams of catechin powder in 25 milliliters of water. Then I prepare the dilutions, transferring 1 milliliter to each tube. Then I transfer my dilutions to my well plate. To this well plate, I added 100 microliters of sodium carbonate and 125 microliters of choline. After that, I incubated my well plate for 15 minutes. For my microemulsions, I prepare each solution. First, I prepare my PCL solution, which for that I prepare it with 160 milligrams of PCL in 10 milligrams of chloroform. And for my PVA solution, I added 20 milligrams of PVA with 9 milliliters of distilled water. For each extract solution, I prepared for my blank 0 milligrams of catechin with 1 milliliter of water. And for my extract solution 2, I prepared it with 50 milligrams of catechin powder with 1 milliliter of water. Then I combine my PVA with my extract solution. Then I did a pre-emulsion for 10 minutes. After that, I took 1 milliliter of PCL and combined it with 1 milliliter of PVA. I did an emulsion for 10 minutes. Then I did a chloroform evaporation with heat and movement. My methodology for my turbidimetric was preparing a wall plate with my microemulsions by triplicating in the wall plate. My first three in the wall plate were microemulsions with 0 grams of EGCG with chloroform. My next 3 were microemulsions with 0 grams of EGCG without chloroform. The next 3 were microemulsions with 50 milligrams of EGCG with chloroform. And the last 3 were microemulsions with 50 milligrams of EGCG without chloroform. For my results, for my cure, I got a catechin 0 dilution with an R of 0.95. And for my FTIR, I got that after removing the water on my microemulsion. We can see the presence of EGCG as well as PVA and PCL. For my turbidimetric results, I had my blank turbidimetric with chloroform, which we can see the drop of the chloroform evaporation, and then it reaches a stability. As well as for my extract solution, we can see the drop of the chloroform where it evaporated, and then it reaches the stability. For my stem results, the one on the left is my blank, and the one on the right, it's the one with 50 milligrams of catechin powder. And we can see that both exhibit spherical appearances, which is a positive result. And here are microscopic results of each of my solutions. One is the blank, the one on the left, and the one on the right, it's the one with catechin. And after the results, we aim a controlled drug delivery method that improves EGCG pharmacokinetics properties that can maximize their anti-leukemic potential. And this can be done by using nanocarriers or advanced delivery platforms. It is possible to enhance EGCG stability and control release, thereby maximizing the anti-leukemic efficacy. And this is something that we're looking forward to developing.